forward motion for a plane comes from the propeller in the air, so it would take off with absolutely no problems. It wouldn't know the difference. So knowing that, let's adjust this experiment to give the plane a chance to move forward, which means, of course, we're gonna need a bigger treadmill. So let's get our treadmill back up to that 10 miles per hour takeoff speed. And at this point, we're exactly back to where we started with the smaller treadmill. So to get the plane to move forward, let's just give it more power, causing it to move down our extended treadmill and take off at 10 miles per hour after 15 feet. Which, as you recall, is the same speed and distance as when we tested it with no treadmill at all. So would your brilliant backyard runway treadmill idea work? Absolutely. Assuming, of course, your backyard is the exact length of an actual runway. And now for our final engineering puzzle, we're back in this hot air balloon as I contend with my mild fear of heights. Okay, well, I haven't found a steering wheel, but it does seem pretty clear every time you add hot, we go high. Hot air balloons utilize some pretty straightforward physics, and the clue is right there in the name. Hot air is less dense than cold air. And we know from our Coke cans, less dense things will rise. So when Mateo does this and heats up the air in the balloon, he's basically Diet Coking us. And then over time, the air outside cools back down the air in the balloon, making it more dense, and therefore we start to sink down like regular Coke. So all you have control over is whether we go up or down.
Correct.
But you said you could land me wherever I wanted.
That is also correct.
But what if the wind's going that way and I want to land over there? That's gotta be magic.
So yeah, so what we'll do is
Okay, pause here, because to understand Mateo's answer, you first need to understand two things.